Okay, so welcome back. Anyway, we came this far, let's go further. Now, we will need those 64 characters that we have talked about. So, const, this will not change, therefore const string and %sign base 64 underline codes equal, and let's type in the alphabet basically. Maybe C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Huh, there we go. I do believe that I'm correct with my alphabet. Although, yeah, if I'm mistaken, feel free to correct me. I will probably do some error checks afterwards as well. One more time, but lowercase. Sing along. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Yep, there we go. And this one is a bit easier. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Lastly, we need plus and slash. That is literally it. That is the end of it. Excellent. So let us proceed onwards. Now, the base64 encode function, which we have, whose prototype we have previously made, we now need to actually construct a body for that function. So let's begin. Std : string base 64 underline encode const std string and %sign s. Yep, there we go. That's it. God. Oh, there we go. Std string ret semicolon. Okay, so just to... Okay, why is it minimized? Yep, there we go. Just to reiterate one more time, over here, nothing new here. Constant reference to a string, that is the parameter that is being passed to the function. String ret, now this will be the output string. We will encode it, we will fill it with encoded characters. Int val equals 0. Yeah, don't hang me if I don't explain absolutely everything in the base64, because base64 is a standardized way of encoding something. And as I said, I don't understand it to the fullest of extents. I understand what I need to understand in the regard of base64, but look it up on the net. This is just pretty much the standard way of encrypting base64. Nothing strange here. I could have literally copy-pasted it from my notes. Int bits equals -6. So why is something here the way it is, or questions of such kind? I will try to answer them if you have any, but I will need to do some internet searching. Anyway, val will be the index we use to map input to our table. Remember, the base64 codes table that we saw previously. And bits -6, well, bits will be used to represent the number of bits in a subgroup. Remember, 6 groups of 6. We will use this basic. Let me just write it down. So const unsigned just means that it's positive always. Int b63 equals. This will be hexadecimal, so 0x3f. So 0x3f, basically that is a hexadecimal. Decimal value is 63. 0x is not the value. 0x says this is hexadecimal. 3f is basically 63. Now, let's go into the for each loop. For each loop is new in C++11. You won't find it in the previous iterations. And we will use it to iterate through the string s. Yes, that will be our string through which we will go. The C is assigned every character from S string. Let me just show you. So we will have a holder, which will be C. That will be the variable. So const auto %C. Why auto? What is that? Well, that's something new, basically. It's when we don't know the type of the variable, and then we just type in auto so that the C++ would recognize in and of itself what sort of a type of a variable that is. And S. So C will be assigned every character from S string. That is what we are doing now. Okay, val equals let's then 8, okay, plus C. Now lesser than stands for left binary shifting. In this particular case, it is a bitwise operation, and val lesser than 8 means that the resulting number will be shifted left by 8 places. It is the same as, let me just do a comparison down below. I can type in val equals val times 2, where's the caret sign? There we go, val 2 to the power of 8. So this part of the statement here till here, and this statement is the same. Comparison. So val equals val times 2 to the power of 8. Simple as that. No super complex stuff there. Next up, we will type in bits plus equals 8, and this will add 8 to number of bits. Base 64 works with octets when extracting information from original string. So yep, there we go. Now we shall insert a while loop. We will nest it in the for each loop. So while bits is lesser or equal to 0, okay, let me just scroll down my notes a little bit. There isn't a whole lot left, so no worries, this won't be some ridiculously long code. Let's just type in ret dot push underline back. There we go. Base 64 underline codes bracket parentheses. Okay, so val greater than sign bits, close it. There we go. And last but not least, we need to go out of this. Type in $sign B63, and we need to close it. There we go. That should be it. There could be a mistake somewhere around here, so let me just have a look a little bit. Yep. Oops. There we go. So that should be it. Anyway, in this while loop here in resulting string, basically it inserts the mapped number. So greater than sign means right shifting, and % sign means binary AND. So 101 and 011 equals 001. Let me explain what ANDing is. So if you have 101, and if down below you have 011, if you perform a logical AND operation, so God, so come on, 1 and 1, that's 1. 1 and 0, that's 0. and 0 and 1, that's 0. So you get 0, 0, 1. Logical OR and logical NOT are function in different ways. Feel free to look that up on the net. So what we're doing here is ANDing to an extent. Anyway, down below we need to type in bits minus equals 6. There we go. Decreases the number of bits by 6. Reason for this is grouping by 6 bits. I've already mentioned that at the very, very, very beginning. So let's go ahead and move onwards. I'm pretty sure that you can follow. If you can, feel free to pose as many questions as you like. But as I said, I'm not the best of experts for base 64. Okay, so next up, we need to go ahead and continue in the, not continue in the for each loop. We'll just go ahead and continue outside of the loop. We need to type in if bits greater than minus 6. At least one character. What this means is that at least one character is inserted. Initial value for bits was minus 6. So if it's greater than minus 6, obviously something has been placed in. Therefore, we will push again. You basically just type in ret dot push underline back base 64 codes, and now this unnecessarily complicated statement, but that's C++ for you. Val insertion, so let's go ahead 8, and we need to close this. Okay, so oops, nope, there we go. Bits plus 8, and then close it again. We shall use ampersand sign B63, and then close it, and end. Complete. So this is how we shall push back in this manner and in this fashion. So if ret size is not aligned, we have padding. So you can just insert equals or equals equals at the end, and the decoder will basically know. That can save you some problems later on. Anyway, not really too important right now, so I'm not going to go into it. Just type in while down below. You can find base64 algorithms on the net as well without bigger problems. You can find them on the forums, syntax, etc. for various programming languages as well. Well, let's go ahead and take the modulus of the ret size. There we go. That before. I don't know, I'm just going to leave it like this. For some strange reason, I should probably place spaces there, but that's just purely for aesthetic reasons. So, ret dot push back, and now the padding character equals. Okay, so what happens here is that the while loop evaluates this. This here is evaluated as either true or false. If it's greater than 0, then it's true. If it's 0, then it's false. That's it. If it's 0, if there is no modulus. Okay, so yeah, but base64 encoding and decoding too, it all happens at the bit level. And yes, base64 heavily relies on bitwise operations on individual bits. And the return will be the encoded string. So let's go ahead and return that string after long last. Return ret, and that's it. There you go. We have successfully completed our encryption. It's over and done with. It's finished. gone for, well, not forever, but hopefully we won't have to come back to this. Anyway, we have two key functions here. It's base64 encode and then encrypt64. So those are the two key functions here which we are utilizing, and hopefully you will find them useful. Bid you all farewell and hope to see you in the follow-up tutorial.